Hello students, welcome to my channel Positron. Just wait please. That's right. Dear student, in the last video I have discussed with you about the formation of image using convex mirror, concave mirror. Before that, when I begin my lectures on the optics, the first video was based on what the light is, representation of light, how the light wave can be represented in the waveform. I have told you all that light is an electromagnetic transverse wave. Why it is electromagnetic wave? Actually, it is represented by three basic vectors, vector E, vector B, and vector K. No doubtly, vector E is a electric field vector, vector B is a magnetic field vector, and vector K is a propagation constant. And then you can represent the light wave as in general you represent a wave y is equal to a sine kx minus omega t. The second video was based on the plane mirror, that how the images can be made using ray diagram from the plane mirror. And then last video was based on the image formation on the spherical mirrors. I have told you all the spherical mirror is a part of a sphere. So the center of that sphere is the center of curvature of a spherical mirror, and radii of that sphere is the radii of curvature of that mirror. Now today's topic is a mirror equation. 1 upon v plus 1 upon u equals to 1 by f. That is mirror equation. And similarly a lens equation, lens formula you can prove. And there is a two important relation, magnification you have to prove, and there is a relation between focal length and radii of curvature, that is f equals to r by 2, that we have to prove. Dear students, first we are going to prove that f equals to r by 2, and after that we will prove that the mirror equation, right, that is 1 upon v plus 1 upon u equals to 1 by f. Dear students, you can consider either the convex mirror or the concave mirror. Concave mirror is a converging mirror that focuses the ray, that brings the rays close to each other after the reflection. Whereas convex mirror is the diverging ray that diverges the ray after the reflection from the mirror. Now, dear students, I am considering this is a concave mirror. I am repeating my words many times, various times I repeated this. The center, the geometrical center of this mirror is the pole. This is the center of curvature. Actually, it is a part of a sphere. This is a cross section of the sphere, you can say, whose rear side is silvered, and this is a part of a sphere. This sphere would have been, if you can imagine, the whole sphere would have been like so on. So the center of that sphere is the center of curvature of this mirror, and this is focal length, right? Now I am not saying that it is the midpoint of center of curvature and pole, because we are going to prove the same, right? Dear students, a ray passing parallel to the optical axis. I am considering a ray which is passing parallel to the optical axis. Now after the reflection from the mirror, it passes through the focus. This is. Draw a normal here, it will meet to the center of curvature. If you draw a normal, it will meet to the center of curvature. How it is? This is a sphere. This is your center. Draw a line from center to the periphery of the sphere, to the circumference of the sphere, to the surface of the sphere. Any line joining the surface of the sphere and center of the sphere is normal to the sphere. All these are normal. So actually this is a center of this whole sphere, and a line has been drawn from center to the sphere. Actually it is a point of incidence of the ray. So this is a normal. Means wherever on this surface you will draw the normal, undoubtedly wherever on this surface of the concave mirror or convex mirror you will draw the line, no doubtly it will meet to the center of curvature. Now dear student, let this is theta. Theta is the ray, this is the angle between incident ray and this is the normal. This is reflected ray. Now apply the law of reflection. First law what says? Angle of reflection must should be angle of incidence must should be equal to the angle of reflection. Angle of incidence is the angle between incident ray and normal. They are just parallel to it. It should appear. Now this angle is the angle between reflected ray and normal. So it is also theta. That is I have applied the law of reflection. Now dear student, these two lines are parallel to it. This is the incident ray. I have assumed, I have supposed, I have taken the incident ray is parallel to the optical axis. Optical axis is what? The line joining center of curvature and pole is said to be the optical axis. So you know that is a geometrical property. This angle will be equal to this angle. Now dear student, consider this triangle. This is the exterior angle, and exterior angle is the sum of two opposite angles, that is theta, so it is a 2 theta. So exterior angle is the sum of two opposite angles of the triangle. Now dear student, draw, let it is a M, draw a perpendicular like this, let it is K. In triangle, if you consider in triangle CKM, this is 90 degrees. The distance between center of curvature and K, we can take it R if K is a very near, very close to P. Actually it is so. K is very close to P. So wherever we consider K, that distance actually we measure from P. P in all the distances in the case of mirror or the lens are measured from the pole, right? So K, we assume actually MP is not exact perpendicular. That is in order to let you understand that I have drawn a perpendicular and assume that K is very close to P. In this triangle, dear student, tan theta equals to MK over CK, or tan theta equals to MK, you can write MP because it's a very close, K is very close to P, and CK again you can write CP. Let it is equation 1. In this triangle, in triangle FKM, tan 2 theta, that is equal to this Fk upon Km, and this Fk can be considered Fp. Again the same concept I am applying, that K is very close to P. So instead rather to take Fk, we are considering Fp. So tan 2 theta equal to Fp divided by MP. That is, sorry, perpendicular. Oh, tan is perpendicular upon this. In this right angle triangle, for this angle 2 theta, this is the perpendicular. So MP over, now FKR, rather I am writing FP. This is equation 2. Dear student, for very small angle, sin theta equals to theta and tan theta is equal to theta. That you can consider. For small angle, tan theta equals to theta. This is approximately equal to, and that is equal to MP or CP. And tan 2 theta, similarly you can write approximately equal to theta, and that is equal to MP or FP. Now dear student, I'm writing here, please look here, 2 theta equals to MP or FP. Just replacing the theta, here theta is equal to MP or CP, and that is equal to MP or FP. What I have done? Nothing special, nothing. Just simply 2 theta was that, and theta was already we have find out MP or CP. So theta I have replaced by this value. Now MP will be cancelled, and dear student, CP you can bring this side, and that is FP this side. This is FP into 2 or CP. The distance of center curvature and pole is a radius, and this is 2 FP, distance of focus from pole. FP is what? Distance of focus from the pole, and that is a focal length F, and you can say F is equal to R by 2. This is the way you can prove that F is equal to R by 2. I hope you should take the screenshot or just note it down. Simply we have proved that the focal length of either be the convex mirror or be the concave mirror, this is true for both of the mirror, that focal length is the half of radius of curvature of that mirror. Now dear students, I am moving ahead. What is next that we have to do? We have to solve mirror equation. Dear student, before going to the mirror equation, you should know the sign conventions that are used in the optics. Most of the students are very much confused while solving the problem, numerical problem, that what to put the values, whether would it be positive or negative, right? So very simple. Dear student, let it is, this is your pole. All the distances are measured from the pole. The distances measured right to the pole are positive. Distances measured left to the pole are negative. Distances measured above to the optical axis. Optical axis is what? That is a line joining the center of curvature and pole is said to be the optical axis. A line joining center of curvature and pole of the mirror is said to be the optical axis, and those distances which are measured upward to the optical axis are considered positive, and the distances measured downward to the optical axis are considered negative. This is positive, this is negative, this is negative, this is positive. Or there is another, in some problems you might be confused. In that cases, what you have to apply? Those distances which are measured in the direction of incident ray, the distances measured in the direction of incident ray are considered to be the positive. Let a distance is that much, right? Because you have to measure the distance from the pole of the mirror. Pole is this. If you are measuring a distance in this way, means you are measuring in the direction of incident ray, and that is considered positive. If you are measuring a distance, a point is P dash, that is left to the pole. In order to measure the distance of P dash from P, you have to come left, means you have to come opposite to the incident ray. In that case, the distance measured would be considered negative. So all the distances measured in the direction of incident ray are considered positive, and the distances which are measured opposite to the incident ray are considered negative. Now dear student, coming to the mirror formula, important formula. This is again I am considering the, for our convenience, for your convenience, I am considering the concave mirror, right? You can consider the convex mirror, no problem. Actually, in the concave mirror, the things are simple. Why? Because the rays are real. In case of convex mirror, you have to make the virtual rays, right? In order to get the image. That is why I am considering, for our convenience, I am considering concave mirror, right? Dear student, this is the pole of the mirror. This is the focus of the mirror. This is the center of curvature of the mirror. And let an object AB, you will say that this object is kept between the center of curvature and infinite, right? You can say that this object AB is kept between the center of curvature and infinite. Let's make the ray diagram in order to find the final location of the image, that where we have to predict that where the image will be found. For that purpose, I am taking a very simple concept. One ray I have considered parallel to the optical axis, and dear students, after the reflection from the mirror, this ray will pass through the focus. You know, the image is what? That is the locus of that point of, that is the locus of intersection of two rays, right? Mirror image is what? That is the locus of intersection of two rays. Now dear student, one day in order to make the image of AB from this concave mirror, what I have done, I have taken a one ray parallel to the optical axis, and optical axis is what? A line joining center of curvature and pole of the mirror is said to be the optical axis, and pole of the mirror is what? Actually it is a geometrical center of the mirror, right? Geometrical center, I mean in simple language you can say the midpoint of the mirror. Another ray you can consider either from center of curvature or a ray passes from focus. Let the array, this is C, a ray, again I am considering that is passing from the focus. Dear student, the ray, from center of curvature, the ray passing from the center of curvature incidents normally on the mirror. A ray passing from the center of curvature incidents normally on the mirror. That is why it will return back to the same path after the reflection from the mirror. Now dear student, these two rays are really intersecting at this point, and so this is a point where image is formed. This was AB, image is A dash B dash. It is clear that the image is real because you have got the image by the real intersection of the rays, and inverted and just has a smaller in size, means diminished. So the image here is a real, inverted and diminished. Now dear students, we have to find the mirror formula. Let it is M. Dear students, I am drawing a perpendicular at this, and let it is P dash. P dash is very close to P, right? Dear student, let's take these two first and then these two. So, in triangle B A dash F and triangle F P dash M, let's talk. This angle is a opposite angle. These two angles are opposite angles, so equal. This angle is a same, right? Both the angles are 90 degrees. Now, dear student, look here. This angle is, now the two angles are same. So, automatically third angle will be same. So, these are similar triangles. What I have taken, the base of this divided by base of this. Now, base of this triangle is AF divided by base of this bigger triangle is FP. FP dash, or you can write my FP, because P dash is a very close to P, right? And now, first base of this divided by base of this, and after that the height of this triangle or perpendicular height of this triangle divided by height of this triangle, that is its height is A dash B dash divided by MP, right? Let it is equation. Dear student, in these two triangles, in triangle A B C and triangle C A dash B dash, what I am doing, I am trying to prove that the two triangles that I am comparing are similar, right? So that you can take the ratio of their size. Now, dear student, this angle is equal to this, undoubtedly it's opposite. This is equal to this, right? And again, these two are parallel, and so this ray, for this ray, this angle is equal to this. So again, these two triangles are similar. The same concept you can apply here too. Now, dear student, in these two triangles, base of this A dash C over base of this AC is equal to height of this A dash B dash over height of this AB in this. MP is equal to AB actually. So you can write like this, AF, just some modification on considering in equation 1, that is AF over FP is equal to A dash B dash over this MP I am replacing by AB. Now dear student, compare these two, you will get what you are going to get. That is I am writing here, this A dash C over AC is equal to AF over FP. We have got this. Now dear student, consider one by one. A dash C. A dash C is what? Look here. The distance of focus from the pole, it is F, focal length. Distance of A from the P, this is a distance of object U, right? Distance of image from the pole, that is a V, right? And this center of curvature from the pole, that is capital R. Now dear student, we have to find out A dash C. A dash C is what? Look here. A dash C, that is equal to A dash C, that is equal to CP minus CA dash. That is CP is a CP, that is a R minus CA dash, that is V. That is R CA dash. The A dash is a point where the image is created, that is distance of image from the pole, that is V. Now I am going to derive the formula. There is no need to consider the sign convention. You do consider the sign convention while solving the problem. Now dear students, this A dash C is equal to that much, and now AC is what? AC, that is AC is a AP minus CP. AP is what? AP is a AC, we have to find out, that is AP minus CP. AP is a U and CP is the R. Dear student, I'm writing here so that you can, this can appear in the camera. Now, this is A dash C, this is AP. AF is what? AF. AF is that much. This is AF. This is AF. Dear student, you can write AF. That is this AP minus FP. And AP is what? AP is actually V, FP is F. And last one, that is FP. FP is undoubtedly focal length F. And also R is equal to 2F. So replace these values in this equation. A dash C. A dash C is R. Here I am replacing R by 2F. So we have got 2F minus V. It was DS, actually it was R minus V. Mirror formula, do not consider, there is no capital R in the mirror formula. It do not contain the capital R. That's why I am replacing R by 2F. It is 2F minus V. So A dash C is a 2F minus V divided by AC. AC is a U minus R. That is means U minus 2F. That is equal to AF is a what? AF is a V minus F divided by FP. FP is a F. Dear student, this is the very equation that we have to solve. Now, easily we can solve this. Now I'm just erasing this to get a space. Now cross multiply. This is 2F minus V into F. That is equal to U minus 2F into V minus F. Multiply this, 2F square minus FV. Multiply these two terms by V, that is UV minus 2VF. Now multiply by these terms by minus F, you will get minus UF plus 2F square. Now dear student, 2F square will be cancelled. Or you can write, this is actually UV equals to minus FV, bringing this to left side plus 2VF, and this also to this side, this is plus UF. Now UV equal to VF plus UF, divide by UVF, this is 1 upon F is equal to 1 upon V plus 1 upon V. Dear student, ultimately you proved that 1 upon F is equal to 1 upon V plus 1 upon V. 1 upon F is equal to 1 upon V plus 1 upon U. This is said to be the mirror formula. This is the mirror formula, that 1 upon V plus 1 upon U equal to 1 upon F. Now dear student, what is called magnification? Let's talk. I'm sure you have taken the screenshot of the solution. Dear students, it was our concave mirror. We have considered the object here AB. I'm not making the ray diagram. While solving the mirror equation, I have made the ray diagram. And the same I'm considering. The image was like so. It was the A dash B dash, right? Distance of object was expressed by U from the pole, and distance of image was expressed in terms of V. Dear student, look here. The magnification is a ratio of size of image to the size of object. M is equal to, this is the size of image. You have to consider it negative. Why? Because it is downward to the optical axis. Over size of object, you have to consider it positive. And now, that is equal to the distance of this ratio is equal to the ratio of distance of image and distance of object. Now distance of image is this. This is also left to the pole over distance of this is the distance of object from the pole that is left to the pole, and this divided by distance of it was a distance of image from the pole and that is left to the pole, so I consider negative, and this is the object distance of object from the pole, it is again left, and thus this is minus u. Dear student, magnification is the ratio of size of image and size of object. Size of image is this I, size of object is O. Image is downward to the optical axis, so I have considered this length negative and this length positive, and this is equal to the ratio of size of ratio of distance of image and distance of object. This magnification is the ratio of size of image and size of object, or it is the ratio of distance of image and distance of object from the pole. So distance of image from the pole is a v, distance of object from the pole is a u. Both u and v, image and object, are left to the pole, so I have considered negative, or you can say m is equal to minus I upon O, that is equal to v upon u, or you can say m is equal to I upon O, that is equal to minus v upon u. This very formula you have to remember, right? This formula we will apply while solving the numerical problems based on the mirror, right? Whenever you have to find out the magnification, size of object, size of image, or the question might be asked that a concave mirror have the focal length 20 centimeter and object 1 centimeter high, object of height 1 centimeter is kept 30 centimeter away from the mirror, then where the image will be formed and what will be the size of image? Such a kind of questions I will solve in the next video. So dear student, magnification is the ratio of size of image and ratio of and size of object, and that is equal to the distance of image and distance of object from the pole. So with these words, I'm just ending this video and promising you to meet you in the next video. Dear students, I hope my videos are going to be beneficial to you. If you think so, that my videos are helpful in your studies, then least but not last, I say that please and please like, share, comment, subscribe my video, and must put the bell icon so that you can be notified about my next video. Meet you soon in the next video. Till then, bye.